Hey guys, I'm working on getting this thing up, so give me a minute. And I'm gonna first go to Facebook and post the link to the agenda. So let me do that. And when you get this, go ahead and make a copy of it. I'm putting this into the Facebook group, and guys, it's just been one of those days. I'm just letting you know. They've changed my whole schedule like 5 minutes ago. So I'm probably going to be up most of the night trying to figure out how to teach what I'm going to teach. So I'm letting you know. Didn't forget about you. We're going to make this work. I think this is going to work. So anyway, I've given you a link to a Google Doc. I'm also going to post in the Facebook group a link to, and you can type that bit.ly to get to the agenda as well. It's the same thing. And then we're going to go to Desmos, because I've basically put this whole training in a Desmos activity. I think that's going to make this easier. I'm really playing with a whole bunch of tools today, so if you think I'm crazy, I sort of am. I really wanted y'all to do this with me so that you could do this. All right, I'm going to go ahead and add the link to the event. I've just added it to the group, but let me add it to the event too. And then basically, this is just a Google Doc. And when you click on it, it's going to prompt you to make a copy. So go ahead and make the copy so you'll have your own, and then you can type in it, write in it, make notes, make another copy, whatever you want to do there. And we'll just make sure you have what you need. All right. So let me get started. I'm going to go to Desmos first. I do have a Jamboard for you guys, and I've got a Flipgrid, and I've got just a ton of stuff. So, and I may try to invite some of y'all onto this. So let me do that. All right. So I'm sure y'all can't even hear me talking, but. All right. Okay, well, my name is Susan Carricker, and I am a school teacher. I do a lot of things, and I decided, I don't even know why. I decided a few weeks ago, you know what? I really want to find a way to do a quality online training. And so I've been doing some research, and then I got this crazy idea that I'm just going to post one, just do it and see what happens. And hopefully you'll get something out of this. I did put together, I think, some pretty good tasks for us to look at, and then more importantly, some conversations that we can have. And I do encourage you, please leave comments, please leave questions. I'm only broadcasting this to the Facebook group, so you can leave your comments on the event. You can leave your comments, and I can invite you in with me. I think I can get up to 6 people in here. So if you want to come on, just let me know, and we will see if we can invite you in. I'll have to figure that part out, but here we go. So to start with, you have a link in your handout, if you go to the handout, to a Desmos activity, and that is called Thinking Tasks. And so if you will go ahead and get into the Thinking Task, the first thing that you're supposed to do is work on, and I'm going to post the link to it too, so. And right now I don't have any students. So let me go ahead and post the link to the Thinking Classroom task, and I'm putting this into the thinking tasks event. So this is a Desmos activity for this training. When you get it, when you click to join, just put your first name or whatever. You could put your Twitter handle. That would be awesome. And then we kind of know who you are and be able to follow you that way. Oops. Let me go back and edit that. I didn't paste it. All right, so there's your student activity. So you go ahead and go into your thinking task. Today, we're going to talk about thinking task for the math class. And we are going to work through some existing tasks. We're going to compare thinking tasks with ordinary exercises and learn some strategies for improving the quality of tasks. And I don't know if y'all are even getting this. Let me get, you learn something new every day. So let me see if I am broadcasting to our group, but I don't see it. So you probably don't either. Here it is. All right. So the thinking task training is broadcasting. I just made sure I'm seeing my face in there. So just jump in with your comments if you want to on that post, and that's where I'm going to be looking for your comments since I don't have y'all set up to come into StreamYard. So today we'll work through some thinking tasks. We'll compare thinking tasks with ordinary exercises, and we will learn strategies for improving quality of tasks to promote thinking. Now, to be honest, this is sort of based on the thinking classroom model. In Peter Liljedahl, I cannot say his last name, his thinking classroom for the mathematics classroom. And it is loosely based on that, but don't be limited by that model. That model is revolutionary, and we are going to do a lot of it, but not all of it because of COVID this semester in my classes. But the part that I noticed as I was reading through the book is he has a lot of non-curricular tasks, and they're great. But, if you're like me and you're teaching an Algebra 1 state tested course and you only teach them for one semester, you have not nearly the amount of time that you might want to do thinking tasks with your kids that are not curricular because you just can't devote too much time to that. A little of that is important. You definitely want to get your kids engaged in the learning, but you do need to consider your state test. So what I would like to do is let's look at, I'm going to share my window here, some thinking tasks. And the first one I gave you this morning, I don't know if anybody's worked it out yet. I'm not going to post answers to anything. So if y'all don't post answers, there won't be any answers posted, and that's fine. But I will give you the solutions later if you choose to do these and don't figure them out. So y'all do let me know. But this is the thinking task for the math class. And the first slide in our task is this one. So let's go to it. A substance is 99% water, and some water evaporates, leaving a substance that is 98% water. How much of the water evaporated? Ironically, I ran across this problem for the first time when I was taking a graduate level math course at the University of Texas in Arlington. And my professor was Dr. Barbara Shipman, and that was the problem. And so we spent nearly I'd say about half of a class period doing this problem. And when you heard the solutions presented by the students, I would say most all of the students were trying to approach this as like an equation or write a system of equations or something like that. So, and that was interesting. And then we were getting answers like 1%, which, if you think about it for 2 seconds, that doesn't make sense. What does it mean for a substance to be 99% water? What does it mean for a substance to be 98% water? Can you subtract 1% like that? What do you do? So anyway, she encouraged us to get away from some of our old habits of using equations and expressions, which a lot of students and teachers do that because that's how we were taught. And she said, "Why don't you try drawing a picture?" And so we basically did this problem, came back the next day, worked on this problem some more. And so what I realized when I read this book, Thinking Classroom, that is my professor was doing this style of teaching. And this was a long time ago. I think it was 2004 is when I got my master's. And then I went back to do some graduate mathematics courses to get my 18 hours so I could do some college courses, teach some college courses. And so this problem, I really, really enjoyed it. I don't know if it's out there. It might be. I didn't search for this one. Most of these you can find online. This is a really fun problem to do with your kids, even your higher levels, especially because they think they know what they're doing, and then they'll realize, maybe I don't. In your Desmos activity, so if you click on the word Desmos in the agenda, you'll come into this activity, put your name, and you can draw on this screen. So you can make a picture of this problem. You can talk about it with someone. You can come back to it. And then I've just put some questions here to kind of prompt your thinking. At the bottom here, you'll notice a link that says Jamboard. And so go to that link to open up your Jamboard thinking task. And there's the problem again. And on this Jamboard, I've got a bunch of frames already made. So that's a problem we're going to do later. But you can go ahead and find a blank screen to work on, or you can work on this one. I just put this one in here inside your thing. So let me show you that screen so you'll know what I'm talking about. So let's go to the Jamboard. And so this Jamboard is just a space for you to work in. And so I've created a link to this in your agenda. So if you'll type, get a copy of the agenda and then go ahead and click on that link, it'll bring you in here. And you're welcome to write. So don't think you can't. You can use a Post-it note and put your name if you want to keep track of where your work is. But the water problem is I would say, a fairly quality thinking task. It is a curricular problem somewhat, but it doesn't really align that well with just algebra. It's really just a good thinking problem and understanding quantities and how to represent things, maybe with diagrams. So I would encourage you to try the problem if you haven't already. So a question that I have for you, and I do want you to enter some things into this Desmos activity if you're doing this training. Please answer these questions and share it out because I want to know what you think. It's not what I think, but what you think. And so Peter has written the Thinking Classroom book. I've given you a copy of an Edutopia article about the Thinking Classroom. So in case you don't have the book or have not read it yet, that you can at least get an idea of what type of teaching and what type of structure he has in his classes. And it's very different from a traditional classroom. Students are not sitting in desks facing one direction, looking at a teacher. They are thinking. They're up on their feet. They're working in teams of 3 at the secondary level. And then if they're really young ones like kindergarten, first grade, I think second grade works in teams of 2. They work on non-permanent surfaces like whiteboards. He said chalkboards would work too. And we want to make sure it's not permanent so that students can erase their work and change their work and they don't feel like it's a permanent thing when they write things down on paper or in pen. They know that it feels more permanent. So with a whiteboard and a whiteboard marker, they can make it non-permanent. The task in his book, Building Thinking Classrooms, he describes the tasks in his book, and he gives some good examples of tasks in his book. But from what I was seeing, not much at all was aligned to the standards of my course. So the purpose of this training is for us to maybe create some items that are aligned to our course. And so my question to you is, what are characteristics of good tasks in a thinking classroom? I'm going to go ahead and put a copy of the StreamYard broadcast for those that would like to jump on. Because some of y'all are not going into this Desmos activity, and that's where I wanted you to type, but it'll be easier if we just type face to face. So I'm going to go to Facebook, and we'll put that in there for y'all. So let's do that. I'm going to put it as a comment on this post. So click on that StreamYard browser-based thing, and I don't know if I can post this, link this to the top. Can I? No. Sorry. I marked this as an announcement, so I don't know if that matters, but it's also under discussion. So come on in. I don't have any comments yet in the in our Desmos activity, but when you get into this is slide 4. So just put what you think are good characteristics of thinking tasks. And I'm going to give you a couple of ideas. It's easier to describe what a thinking task isn't than what it is. It is not traditional exercises that have one right solution. If you're like me, when you took your math classes in high school, almost all of your college courses, the professor or the teacher would give you an example of a problem, and then you would practice that problem together, maybe do another one together, and then they would say, okay, now you try this one by yourself. We call that model I do, we do, you do. So I help, the teacher does the work, the student does a little bit of work with the teacher, and then the student works alone. That's the model. Well, the thinking classroom is completely reversed. We start with the students working, and they take all the information that they're given and they try different approaches to see what sense they can make of the problem. And as they work, they get ideas from other students in their group or students in other groups to put together their thinking. So they work actually with their teams first. Then they work as a whole class. The teacher can come in and interject questions, comments, maybe some more information, can direct the conversation to help the kids get closer and closer to that information that they need. And then finally, the teacher does step in at some point to give them additional support, to give them additional information. So the teacher is the last, not the first thing. The students are doing the work, and the teacher is a facilitator in that environment. So that's what sets a thinking task apart from a ordinary exercise. Our next task that I want you to look at is the geometry task. And this actually did come out of a textbook, but I do believe it's pretty novel. So I did include it as a thinking task. It also gives us an opportunity to kind of combine some geometry and some sketches and to make sense of something in the real world. On this problem, it is on your Jamboard. So if you will click on the Jamboard link on this slide, which is number 5, you can go directly to this task and work on it. I've given you a tool here to draw, but there's not quite as many tools here in your, you have a line tool, you have a pen tool, you have an eraser, and you have different colors. But if you do Jamboard, you can draw some Instead of just drawing your, I'm not very good at this. And I'm going to show y'all something really cool. Let me go back to the Jamboard, which I think I'm already on that. Yeah, I'm not doing too good, guys. All right, so let's go back to the Jamboard. I've been on the wrong screen this whole time. And I'm going to show you something with the goat problem that you may not know. All right, go to the goat problem. This is actually on slide 2. If you'll use the pen tool, let's see, brush, highlighter, marker, pen. You can draw lines, but watch this. If you hold, I believe it's shift and draw your line, look at this. It makes straight lines. Hold your shift button down as you draw on your Jamboard, and you can draw the perfect rectangle. So if you want to draw a rectangle, you can do it. Now, that's probably not the smart way to do it. So I'm going to go ahead and delete all this. Oops. It's not letting me select it. So I'm going to have to erase all that, or I can clear my screen. But it's a neat little tool. They do have shapes in here, so you can use your shapes. So come over here to your shapes button, grab this, and then you can draw your little shed. So there's the shed. You can label it. If you want to put text box, you can label it 15 by 12. And then you need to basically look at the question over here. So let's look at it. It says the goat is tied to the corner of a 15 by 12 shed. What is the area grazed by the goat if the rope is 12 feet long? So if the rope is 12 feet long, so you'd have 15 and 12. So if you put it on the corner, the goat can go all the way to this corner, and then he can't quite go here. So what would that look like? I'm going to leave that with y'all. And then I took that same task. If you go back to slide 6, and I'm going to go back and do screen share again, and we're going to do okay, so this task, the goat task, once you're finished with it, I've extended this by extending the rope. So what if the rope was extended to 15 feet? How would that affect this task? And so you could expand your drawing or make a new one. And what would happen if the rope is extended to 18 feet? Now I'm giving specific numbers. So this isn't the perfect thinking task, but it's a good starting point. So if you've never done a task like this and you have a geometry class, this would be a good one to do. But let's do a checklist here. And this is how to ruin a thinking task. What behaviors should we avoid if we want to use a problem like the grazing goat as a thinking task? And so these are your options. Completing a worked example of a similar problem for students, drawing a detailed picture of the scenario for the students, working areas of sectors exercises like right before you give them this with the students, and then giving opportunities to work in teams. So those are your answers. So here it says select all that apply. I'll let y'all do that. But let's keep going. When you go through the thinking classroom structure, one thing that's very important, and it's right up front in the book, is visibly random grouping and vertical non-permanent surfaces. But are these two possible in your current setting? For example, a lot of schools across the United States are now 100% virtual, and they are not meeting face-to-face due to COVID safety concerns. How do we do visibly random grouping and vertical non-permanent surfaces in that circumstance? And then you have the other side, and that would be like here. I am actually meeting face-to-face with my students tomorrow, and the vast majority are coming. So I think I have 2 distance learners in one class and 3 or 4 in another, and then the rest of the students are present in school face to face. But even if they are present in school face to face, can I put them together in groups of 2 or 3 on vertical non-permanent surfaces? Not really. I think some teachers in our district some kind of push that a little bit and maybe do that every once in a while. I did have my kids go to the library and spread out and each do a big poster on a table last term, which was almost against the rules. And a couple of them kept working together. They weren't supposed to. So I don't think I could get away with that, especially if I were doing it every day. So there are some considerations because of COVID-19 to think about. So the second question is, if you can't do it, what could you do as a replacement? What are things we could do that may not be perfect, but would get our kids closer to that thinking classroom model? And one thing I think about is Jamboard. I mean, Jamboard is a non-permanent surface. It is a whiteboard, so kids can represent their thinking. They could draw. They could even draw on paper or these mini whiteboards, which I'm probably going to go get one and show you one in a minute. But you could draw on that, and then you could share that virtually. You could share it in a Google Meet. You could share it in a Zoom. You could use Jamboard inside your Google Meet. So this is a way to have your thinking classroom structure somewhat with visibly random groups on vertical non-permanent surfaces. In other words, digital non-permanent surfaces. So on this slide, I'm in the Google. I'm actually in a Desmos activity. If you click on the word Desmos in the agenda, so there's your thinking task agenda is a bit.ly link. If you click on that, thinking 2021, then you will see there's some cards here describing some activities, and then you are to categorize them into thinking tasks and ordinary exercises. So let's see. I'll do this one. Solve quadratic equations by factoring or with a quadratic formula and check by graphing. So I don't know about you, but I've probably done 1,000 of these in my day as a math teacher for 35 years. So this is definitely ordinary. This is something that would show up in just about every textbook out there. I'll let y'all do the last 3 yourself, but do sort these into categories. If you have never done a Desmos activity or created your own, these are pretty easy to put together. I would encourage you to use these with your students to help them make sense of things, to create some tasks like this. Now, here's a non-curricular task that I found, and I've actually given you the resource so that you can go back and use it if you want to. And it's called the birthday card task or the magic birthday trick, or there's several names for it. But basically, if I ask you, what is your birthday? And you give me a number between 1 and 31, because there's 31 days in any month, or 31 or less, choose all the cards that contain your birthday. So my birthday is January 13th, which is coming up next week. And I would choose the cards that have the 13. So if you look at card 4, there's no 13. And if you look at card 3, there is a 13. And so is card 2, that is a 13. And then card 1, no 13 on card 1. But card 0 has a 13. And so what I would do is I would tell you, let's see, yeah, my birthday's 13, but I know that. My point is, if you tell me your cards, I won't necessarily know your birthday before you tell me your cards, but I will 100% of the time be able to tell you your birthday. And so there's a trick to that. Have somebody, well, I can't really tell you the trick, because if I tell you the trick, I'm doing all the thinking. So I'm going to leave this for you. This is another task that you can try, but the solution's out there, guys. You know it is. And I'm going to show you something anyway that has it in there. But I want you to try this thinking task yourself, so you can kind of experience what it's like to get a problem that's a novel problem. Non-curricular tasks are pretty easy to find. In fact, I've given you a link here to an amazing resource that is filled with non-curricular tasks. It's not that they're non-curricular completely, they're just not the standard Algebra 1, Geometry, Algebra 2 sequence of high school courses curriculum. So it is mathematics curriculum, but it's just not the mathematics curriculum that most of us teach. So I shouldn't say they're completely non-curricular. But if you'll click on that link, you can find that problem, a lot of extending questions, and many, many more thinking tasks to go along with it. So that's your incentive to go and click on that Desmos activity and jump in, because this is on slide 12, is a link to an amazing resource. But even routine tasks in our curriculum can be improved with simple changes. So now you may not make them perfect, but they will improve. And so what are some changes that you can do to make an improvement in an ordinary exercise? And so these are your selections. Is first one, make this question have exactly one right answer using a step-by-step process. 2, make an opportunity for creativity or exploration. 3, make more than one strategy or more than one solution possible. And then finally, make an unusual or an unexpected outcome. So something you don't typically expect to happen. Those are good tasks to grab kids' attention, especially when you first start doing thinking tasks. So I think y'all know which one not to pick, but I'll let y'all check that. All right, so now we're going to talk about a video that's super important. It's longer than I'm going to play, but I do want to play a clip of it. And this is Dan Meyer, and he basically recorded a TED Talk 10 years ago. And he figured out what we're talking about today and what's in this same book, and actually many other books I've read. In fact, when I got my master's degree, I read Lynn Erickson's book on critical thinking, and so some of the ideas in her book follow along this same path. She's not nearly as radical, of course. She's more of a traditional teacher, but her ideas are in his approach as well. So it would be good to check her out. But I do want to play a portion of this video. So I'm going to click on this, and I don't know how to do this without.
So 90% of what I do.
All right, let me share this.
Take fairly compelling elements of problems like this from my textbook and rebuild them in a way that supports math, reasoning, and patient problem solving. And here's how it works. I like this question. It's about a water tank. The question is, how long will it take you to fill it up? Okay. First things first, we eliminate all the sub-steps. Students have to develop those. They have to formulate those. And then notice that all the information written on there is stuff you'll need. None of it's a distractor, so we lose that. Students need to decide, all right, well, does the height matter? Does the side length matter? Does the color of the valve matter? What matters here? It's such an underrepresented question in math curriculum. So now we have a water tank. How long will it take you to fill it up? And that's it. And because this is the 21st century, and we would love to talk about the real world on its own terms, not in terms of line art or clip art that you so often see in textbooks, we go out and we take a picture. Now we have the real deal. How long will it take it to fill it up? And then even better is we take a video of someone filling it up. And it's filling up slowly, agonizingly slowly. It's tedious. Students are looking at their watches, rolling their eyes, and they're all wondering at some point or another, man, how long is it going to take to fill up? That's how you know you baited the hook, right? And that question off this right here is really fun for me because, like the intro, I teach kids because of my inexperience. I teach the kids that are the most remedial, all right? And I got kids who will not join a conversation about math because there's like someone else has the formula. Someone else knows how to work the formula better than me, so I won't talk about it. But here, every student is on the level playing field of intuition. Like everyone's filled something up with water before. So I get kids answering the question, how long will it take? I got kids who are mathematically and conversationally intimidated joining the conversation. We put names on the board. attach them to guesses, and kids have bought in here. And then we follow the process I've described. And the best part here, or one of the better parts, is that we don't get our answer from the answer key in the back of the teacher position. We instead just watch the end of the movie. And that's terrifying, all right? Because the theoretical models that always work out in the answer key in the back of the teacher position, like that's great, but it's scary to talk about sources of error when the theoretical does not match up with the practical. But those conversations have been so valuable, among the most valuable. So I'm here to report some really fun games with students.
All right, so we're going to go back to, let's get rid of that. All right, so we're back to our Desmos activity. So if you haven't clicked on slide 13, I do, if you've read the book Thinking Classroom, Peter Liljedahl's, if you've read his Thinking Classroom book, what do you notice about the approach in this video that was written a decade ago and how that compares to this book? What do you notice? So let me share a screen if it'll let me. Hold on. So how is it similar to his approach in the Thinking Classroom? I really loved the example that he gave, and I've actually given you an example of something that reminds me of that in a minute, 2 of them even. So I wanted you to have an opportunity to kind of think about a problem like that. You'll notice we're not really working through these problems, and we should, because that is the really most powerful part of the Thinking Classroom is when we work in teams or pairs to figure these out. Unfortunately, I've worked these problems before, so I would kind of have an unfair advantage. So it's better to get people that don't really know where they're going to experience it, truly experience the Thinking Classroom model. But I loved how he removed all these intermediate steps from a problem, and he took away even the numbers and just started talking about how long is this going to take, and let the kids come up with the detail. Feel free to post something here and share that out. All right, I've moved on to slide 14. I love this problem. This is one of those unexpected, it's an unexpected problem. So it's called the sliding ladder task. And I've done a problem like this in a pre-AP curriculum called Laying the Foundations. And if you've never heard of it, they're now called the National Math and Science Institute. I think they bought them. AP Strategies is another one. But you know what? This kind of question is actually good for even lower level kids. Because when you ask this question, and I'll just go ahead and tell you, most people will say if you pull the base of the ladder out from the wall at a constant rate, then of course the top of the ladder is going to move down the wall at a constant rate. And that's usually, they'll all say that, or I said it too. I remember as a student working a problem with like this and thinking that, and then you do the math and you start to think, wait a minute, that doesn't seem to be true. And if you'll recall, and we actually did this in class, we took a little, I don't remember what it was, but I took something and I pulled the base out with the kids in class and they would, but see, here's the difference in a Thinking Classroom. I would not be the one doing that. I would give them a ladder, a little ladder maybe, and have them do it and then describe, measure, quantify what they're seeing so that they come to a realization that the top of that ladder may not be moving down that wall at a constant rate. And then we can go even further. Give me some specifics, give me some numbers. And so they could actually create their own. But this is a really good task, especially in geometry. If you're doing the Pythagorean theorem or you're doing trigonometry, you could use this type of problem and a host of other ideas to go with it to create your own thinking task. So on the geometry theme, let's move on to slide 15. So if you'll go to slide 15, we have how can we improve this cone problem. So what I did is on the Jamboard, now to get to Jamboard, for those of you arriving late, there's a link to Jamboard in the Google Doc, and there's also a link to the Jamboard back on, what slide was that? I don't even remember. It's the goat problem. Yeah, it's slide number 4. So if you want to go back to slide 4, if you didn't grab that link, you can go out to the Jamboard and work there. Because in here you're kind of limited on your tools. But if you want to draw on this or write on this, here's the question. Water is dripping from an inverted cone into a right cylinder that has a radius of 8 centimeters. The slant height, which I don't know if that's a proper term outside the geometry class, but we call that that side length or whatever, the slant height of the cone, is 12 centimeters. And the radius of the cone is 6 centimeters. So the cylinder has a radius of 8, and that's the one at the bottom, and the cone has a radius of 6, and that looks reasonable. The water's dripping from the cone at a rate of 2 cubic centimeters per minute. Interesting. How much water has dripped from the cone in 4 minutes, and what is the height of the water in the cylinder after 4 minutes? Now, this is not really the best thinking task. How can we improve this problem to make it a better thinking task? What are your thoughts? Well, if you compare this task to the task on slide 14, which is the ladder problem, you will notice that in the ladder problem, there's nothing there. There's just the scenario. And it does talking about moving the base away at a constant rate. So that's some information there. And it's talking about the top of the ladder moving down the wall. Is it moving at a constant rate? But on this one, you've got some specific information. You're given the dimensions of the cone. You're given the slant height of the cone. You're given the radius of the cylinder. And you know what you're not given? And that's even a good question too. Do you need the height of the cylinder? Maybe we should include that too. Do we need that? These are good questions to ask. And so this question, you might have a kid create a question with this diagram. Those are some of the best. If you have an advanced class, please do that. They will give you some amazing questions if you will let them create questions. So, but you know what? Give your lower level kids that opportunity too. They'll amaze you. All right, so I'm now on slide 16, and this one is really a stripped down question. You have a unit on linear equations, and you have one ordinary exercise in your textbook, 3x plus 1 equals 16. How could you change this and make it and develop it into something that is more interesting? Well, I can tell you what I always do. If nothing else, if I cannot come up with anything more interesting, then I will take something like this and I would convert it into some function in Desmos, preferably with sliders that we can analyze and play with. So I will show you something like that in just a minute. I'm going to give y'all some links out to some activities that take these ideas and let kids play with the math before they actually learn the concepts. Or even if they already know the concepts, to stop and analyze what's really taking place. So on slide 16, if you have any ideas, what would you do if you wanted kids to solve equations, but you wanted it to be more interesting, at least closer to being a thinking task? This is definitely not a thinking task. Oh, good. Carl's in. Awesome, awesome idea, Carl. In fact, this could probably be your go-to strategy across the board. Instead of giving direct instructions, solve the equation, allow them to create the equation with like an open middle problem. And you know what? I didn't put a single open middle problem in here. So that would be something really good, a good resource. I think I'll add it to the handout. Y'all need that. Yeah, we could say, okay, I'm going to leave boxes blank x plus blank equals blank. You can make it way more complicated too. You could add more, make the equation more interesting and let the kids come up with different correct answers. That's awesome. Again, an open strategy, more than one solution. So these are characteristics we want to look for in a thinking question. All right, here's another one. Ordinary exercise. I've got a function f of x equals x squared minus 3. I've got another function g of x equals the quantity x minus 3 squared. And I'm asking kids to graph these two functions. Okay, that's a pretty straightforward task. Not sure they're going to be thinking that much about it, particularly if they got the calculator. They're going to type it in there. And in my class, they do screenshots and they drop them into a Google Doc because we don't use paper right now. We're trying to keep it digital. But how could I change it to more than just a straightforward graph? What could they do to create something that's a thinking task? What are some ideas that you have that you could do to make this more engaging and more interesting? We have to teach this concept, graphing quadratic functions, but what are we doing? How are they the same? How are they different? Very good. Can you predict how the graphs would be? Yeah. How they would differ. It's interesting, they do have a lot of similarities. They both have the square and they both have a minus 3 in there somewhere. But it does make a difference, doesn't it? You know, one thing, and it's super fun. I mean, why is the x minus 3? I mean, we know as a math teacher, the HK is the vertex of the quadratic function. We memorize these things. We just know them. We don't ever stop to go back to when we did not know them to try to approach it in a completely different way. But have you ever thought about why? You know, the kids always ask me, why, teacher, does it go this direction? Shouldn't it go that direction? Those are good questions for kids to be grappling with. Not just what does it do, because that's important and that's on state test. Which way does this go? If you compare it to the parent function, y is equal to x squared, which is our baseline. But why does it do that? Why does one of these do what you think it should and the other one's kind of going backward from what you think it should? What is making it do that? How does that work? Let me give you another resource. I'm just going to shout it out because you can go look it up yourself. It's called Text Teams. TEXTEAMS. Text Teams. Algebra 1, 2000 and beyond. It's super old. It's super old. But you know what? They have these really cool exercises in there where they do problems like this and the kids make sense of it. It's a little bit too scaffolded. I would say take a lot of that out if you're going to make it into thinking exercises or thinking tasks. But you know what? They're really good. They're good. All right. Now, I did have a free play, an idea for a thinking task. Let's brainstorm ideas to make it awesome. I didn't even really give you a place to type that. But what I do want to do, if you've got your agenda, and let me go ahead and stream the agenda. If you have not gone to bit.ly/thinking 2021, do it because I've given you some more resources there and I'm about to show you. Oh, is Dan still? Dan, are you in there? Did I mess up? Almost banned you. Hold on. Let me remove that and I'm going to share my screen again. Where am I? Man, I got so much open, guys. I'll get it. All right. So in the Google Doc, I just wanted to point out a few things to you. First of all, that thinking task, you can go directly to that task here. So click on this link and it'll take you to the Desmos activity. You can go all the way from start to finish. Please add your comments and read the comments of the others that have left comments, because you're going to learn more, I can assure you, from some of the people that are in this group than you will from me. I've been on the conceptual thinking bandwagon for many, many years. I've been teaching for 34 years, and it was about 10 years in that I took a major detour and started teaching from a more conceptual approach. So in that respect, I've been on this bandwagon a long time. But the other side is I have not relinquished enough control. And I only did so this past semester, and I did not do it in this manner. I did a lot of different things besides this, but I am going to implement the thinking classroom, not with fidelity, but closer to their model this term. So I am committed to doing it. So the water problem is here, and the link to the Jamboard is here. So you're welcome to go into that and click on that, create your own frame, add a note to someone else's frame. Just be respectful. And if you want to pair up or team up and work on it, do it. I will secretly give you the answers somewhere, but I'm not going to post those publicly, mainly because I want to leave these problems out there for people to work on because they're fun. The second thing we talked about is what is the difference between ordinary exercise and a thinking task. And so in this document is a place for you to type those thoughts. And then, of course, read the thoughts that are in the Desmos activity. If someone else has a point that you hadn't thought about, what makes something a good thinking task. Here's the goat problem, the grazing goat. Here's the mind reading trick. By the way, you can Google this answer. I found 6 sites that had it. So it's very easy to find the answer. But try to approach this without looking at that first if you haven't already done this problem, because, I was lost. I'll be honest, till I found out what to do. I was like, I don't even know. I would have had a hard time approaching that problem. But it is a really good thinking task. It's much harder for folks like us because we were raised on a very straightforward, direct teaching model. And here's some considerations. Curricular thinking tasks are harder to find. Really good ones are really hard to find. And they are also harder to create. Here's our dilemma. We are in a course where we are told we have to teach students to do specific strategies, right? We are also told to do problem solving, and we are to do best practices, math thinking practices. We are supposed to do that, but we are also supposed to teach kids to do the ABC, different skill level tasks. So making a task that incorporates those things and is a thinking task is more challenging. But just know this, any thinking task, whether it's mediocre, is still better than an ordinary exercise. So do not be a perfectionist. Do not wait to get started until you have the most perfect curriculum in place, because guess what? There's no such thing. You'll get it closer, but you're never going to get it perfect. Take what you've got, add in another thinking task, and continue to get better. And each year you grow, and each year you realize, that wasn't really a thinking task. I'm going to take it out. And then finally, don't be afraid to choose problems you don't know how to work. I've given problems to my kids that I was like, I have no idea how to do this. But I had students that figured it out. I'm thinking this birthday card problem would be that. Ask some of your computer programming kids how to do that. They'll know. Here's the sliding ladder task. So you could cut and paste that if you want to give that to your kids. Fabulous question for a trig class. Fabulous question for a geometry class. Or for any class, really. That's just fun. Here's the cone problem. I did give you an editable drawing, so you could click on this and edit it if you want to put the numbers in there, or you could delete all the numbers if you want to make that better, because honestly, that's one way. On Twitter, I'm going to give you some things to do if you haven't already done it. If you've never looked at the MTBOS hashtag, that's Math Teachers Blogosphere. This is teachers that blog that also teach math. The I Teach Math hashtag, these are for math teachers. EduTwitter is just a generic hashtag for people that are educators on Twitter. And EdTech. There are many, many more, but these are the 4 primary ones that I follow, and I know a lot of really great people that follow them. Now, this is kind of bonus. And this is more bright ideas. So what I have done for you to play and to give you some more ideas to use with your kids is I've created a graspable math activity that's open. And so you will click on this link and you will go to graspable math. And I'm not going to do it for you. I've already actually done the first one, but over here on the left side of your screen, and I guess I need to share this because y'all are not seeing it. Give me a second. Yeah, I wish they would change this where I could jump from screen to screen. I know, I'm just going to do my. Ooh, I can't do that one. I got too much stuff open, guys. So I apologize, but let me look at this. What was I doing? Oh, yeah, graspable math. These are the type of activities that you do not have to do direct instruction first. In fact, I discourage you from starting tasks like this, especially because these are kind of boring. When you teach out of a textbook and you give a kid an example and you say, okay, here, do this, and they copy you, they're not going to remember what you're doing. But if you give them one like this, where they have to play with the numbers and try to make sense of them, and these are not ordinary, by the way, they don't follow. I mean, look at this. What is this? So I need this to be where? And so if they already know, then they can take this and move it up. And you see what it's doing? And you know what they're going to say? It's moving left and right. And you're just thinking, okay, I guess that's true. It's actually moving up and down too. But yeah, and then I need this graph. Does it need to be steeper? So you would grab this number, if I can get it to go up. And then I can make this number bigger, and I can make this number smaller. Let's make it a 1. And I'm not going to finish it because I don't want you to see it. But as soon as you do it correctly, what will happen is this will turn green, and you're going to go to continue until you get it. And so your job is to make your line up with the other line. And so kids, what's happening is they are intuitively figuring out what's going on. You're not answering the question or showing them directly how to do it. They're making sense of it. And then you know what's even better is having kids tell you what they're doing. You know, I don't know how to do this. Class, how do you do this? And you let them get up and demonstrate. They're very proud to do that. The book does tell us that the kids don't really listen to each other, and that is true. But for an activity like this, they might because they really want to do it and they enjoy doing those type of activities. So let me go to the doc again. And let me share my doc. And then I want you to click on this link down here which says Desmos Activity. Now you're already in Desmos, so what the heck? But this is a different one. So I'm going to open it up. I don't think we're going to go to it right now, but I do want you to try to do it. It's basically the same type of activity. So you're going in as a student, just type your name and go in there and play. But in this activity, you are trying to match a line. So again, you're working kind of backward, which makes this more of a thinking activity and not a direct taught concept. So you're not saying, here's an example and I do one just like it. You're having the kids create what they believe works, and then eventually they're going to get it. But that's how that works. And then the GeoGebra is another one. Let's see. For this one, I'll get. This one is really not. This really is just play. In this one, there's not an activity. It doesn't say they have to do a certain thing, but this is really more of an exploration. So what they do is they go to this board and they drag those points around to change the shape of that triangle. So they're making the line steeper and flatter and positive slope and negative slope, and it's showing the changes on the side of that right triangle. And I actually call those a slope triangle when I do my teaching. But a great thing to do is to have them do an exploration. Tell me what this is doing. What does this mean? What do you notice? Let them tell you. Maybe they can come up with some good questions and answers before you teach it. So again, getting an intuitive understanding of what's going on is really the biggest part of the thinking classroom. In my opinion, it's what makes it work. So if you can get kids engaged in an activity and thinking about the activity before they're given any specific information about it, then when you do give them any specific information, they have something to attach it to, and it's going to last longer. They're going to remember it better. And the data shows that. The data shows it not just in my classes, but in a lot of people's classes. When kids are playing with the math, doing stuff with the math, making sense of it all by themselves, even if they don't understand it completely, if they've got even just a little bit of understanding, then they can make more sense of it. And then a final note I put in your handout is kids can multitask. And I'm going to show y'all something because you're going to be kind of blown away. Let me get out of here. I'm going to go to my Google Classroom because I want y'all to see what these kids were doing every day. Unbelievable amount of work. And I'm sure you're thinking, oh, that's just too much. You know what? These kids do 500 things at once. And I don't know if you've noticed, but I'm going to share with you a different screen. So pause here for a second. Let me do that. Stop. Share. Yeah, I'm going to share with you an application window. Where is it? No, that's not what I want. Yeah, I can't do it because it's on the wrong thing. So anyway, but let me just show you when I teach my classes on the board. On the board in the classroom, I will list out like 5 activities every single day. In Google Classroom, I list out 5 activities every single day. So the very first lesson in my algebra class, which is starting tomorrow, they're going to do a Desmos activity. We're actually going to do the turtle crossing, which is super fun if you want to do a review of functions. Again, it gives them an intuitive understanding of what makes a function and how that works. And then we're going to go on and do some GeoGebra, and then we're going to do they're going to do a little thing where they make an infographic of their name. So they're going to be super busy doing all these different tasks. And when I first started, I was going super slow and they were so bored. And so now they're never bored. Every task is distinctly different. Every day they're doing something that's intuitive that they can play with. They don't have to know the math necessarily to get started, which removes that intimidation factor. And then what's amazing is when they do it, they actually do learn it. So I'll give them a quiz or a test on Friday, and man, the scores were out the roof and I couldn't believe the difference. The scores were great on these more traditional assessments, and I did not expect it. I was kind of willing to sacrifice those scores to give them a better learning environment. And what happened is they actually learned the stuff better anyway. They even learned the boring stuff, if you will. And students would come to me, I could just put this here and that would give me this answer. Is that okay? And I'm like, yeah, that's okay. So they discover for themselves shortcuts without you having to teach them directly. They really do a good job. All right, guys, it's been an hour and it's been a sloppy mess, but I did this for free for this purpose because I had never worked with StreamYard. And so I've learned a lot, and I've never broadcast from one place to Facebook. And yeah, this kind of limited because I'm on the free plan. I'm probably going to have to spend some money. But I did want to give you access to some of these problems and give you an opportunity to share your thinking. And since not many people showed up, at least synchronously, y'all can still do this just like we do in distance learning. It's never too late to learn. So you can jump on this Desmos activity. You can jump into this thinking task agenda. You can work on these problems at your own pace anytime you like. And of course, you can ask questions because that's what this is all about, is learning. I hope you've learned something. I hope if you've gotten even one nugget out of this, that it was worth it. And we'll do another training in the future, hopefully a little more professional. Y'all have a great day.